today I'm going to show you how to sketch cubic graphs that are in root form or factor form. So I'm going to show you the general equation for our root form. You'll know from quadratics, I'm going to use Q, could use any letter there. Remember M, N and Q are our roots once we've solved, or our solutions once we've solved them. A is our dilation factor. Now, when you've got a cubic in this form, it can take two forms. If it's positive, a positive cubic will generally take this form. Now, obviously, it depends where your roots are. If I go like this, where you've got 1, 2, 3 roots, where this would be, any of them, depends what they are. Your M, N and Q, obviously, this indicates they're all positive, but depending on what their signs are, this could be M, N, and Q, for example, and that's what we call a positive cubic. It's going in that direction. It's just that the point of inflection that we saw in the point of inflection form isn't there. It's being extenuated, being stretched up here, so it's opened out into what we call a maximum and a minimum. We don't need to give the coordinates of these maximum, minimum, or turning points at this stage. So we don't need to worry about that. All we need to worry about is, can we get any y-intercepts and any x-intercepts? And of course, a negative one in root form could take this form where it's going in the opposite direction. Something, oh, sorry, I got a bit carried away there. Something in that form, of course, that goes down to negative infinity down this way, up to positive infinity up there. And again, here are the roots on here, here, and here, which are our x-intercepts. Now, as long as you know this is what a positive one looks like and this is what a negative one looks like, once you've found your roots, obviously it will depend what they are as to where this is shifted along, and your y-intercept, that's all you really need to do for a sketch of anything in this particular form. Now let's talk about what happens if you have a double root. So something in the form of x minus n. I mean, obviously making up letters here, but let's suppose it's x minus m all squared. Now let's have a look. Depending on whether it's positive or negative tells you which direction it goes in. Let's just look at a positive one. I'm just going to draw a positive version with what I'm calling this double root. And it's likely to take something like this, where this root here, this double root, just touches the x-axis. So that would be your m. Obviously, if that was positive, that would be your n. But it gives you sort of the idea of the direction and what it would look like. So it doesn't actually intercept here, but it is a solution. All right, so we're going to sketch this graph. We can see it's in root form. Just looking at how we do the solutions. Oh, before I do that, we look at the sign of A, and we can see it's a positive cubic, so we know it's going to go in that direction. We can also see that the roots will be our x-intercepts. So let's do that first. So don't forget our x-intercepts occur when y equals 0, and we're technically using the null factor law to solve this. So x minus 1 equals 0. Solving that gives us x equals 1. X plus 2 equals 0. Solving that, x equals negative 2. And solving this one, x plus 1 equals 0. Then x equals negative 1. So we've got negative 1, then negative 2, negative 1, and 1 as our roots. Let's have a look at the y-intercept then. The y-intercept occurs when x equals 0. So let's put 0 in for x. Okay, so y equals 0 minus 1 multiplied by 0 plus 2 multiplied by 0 plus 1. So working that out, minus 1 multiplied by 2 multiplied by 1, y equals negative 2. All right, so I'm going to sketch this. We've already got the shape. So I've got some roots over that side. Make sure you label your axes. We've got the right shape. We've got 2 negative roots here. Okay, and we also have a y-intercept of negative 2. So label that. We've got minus 2, minus 1, and 1 as our roots. And that's pretty much all we need to put on a sketch when a graph is in root form.